Okay, 9 part 2 is quite a tricky question if you're not sure how to approach it. We've gone up in marks. It's a 5 mark question now. So we've got the same quadratic as before. And it says the line 3x plus y equals c is a tangent to this curve. Very first thing I'm going to do is just rewrite that in the form y equals mx plus c. I don't know why they didn't do that in the first place, but maybe just to try and trick you. And we can hopefully see here that the gradient is -3. So the gradient of the tangent is -3. So that's like there somewhere. It's probably not. Let's try that again. Let's guess that it's here. So that's my line here, and it's asking us to work out c, which would be the y-intercept. Now there's a couple of ways to approach this question. What we could do is we could treat it as a pair of simultaneous equations and say that the equations, when they meet, have to only have one solution. Because if they had more than one solution, it wouldn't be a tangent. And we know that equations that only have one solution are equations that have a discriminant equal to 0. So I'm going to do that method, and it was, I think, a very similar question to the one on the last year's paper that lots of people found really difficult. So I'm going to use that method again just to reinforce it, but I will show you another method too in case you're more comfortable with that. So we're going to, basically the strategy is to find the discriminant, make it equal to 0, and then use that, rearrange that to help us find this c value here. So in order to do that, I'm going to move everything over to the left hand side so that it equals 0. Make it look neater, tidy it up, so 2x squared plus 4x, take away 10, and take away c. So if I write that as 10 plus c, I've got the take away 10, take away c, and it means I'm less likely to make a mistake here. So as I said, we want the discriminant of this to equal 0. So b squared is going to be 16 minus 4 times 2 times minus, which means I can just turn that into a plus, 10 plus c. So that's 16 plus 8 lots of 10 plus c. I can divide everything by 8. So if I divide that by 8, I'm going to get 2. Divide that by 8, that's going to go. So we're just left with 10 plus c is equal to 0. So c must be -12. The alternative method, if we go back to the diagram, is to say, well, I know at this point here, the gradient of the line needs to be equal to -3, because that's the value of the tangent gradient. So if we differentiate the function and make the gradient equal to -3, then we should be able to find c that way, because they will share a y coordinate. So let's rewrite the question. We've got y equals 2x squared plus 8x take away 10. And we've also got y equals -3x plus c. Oops, 3x plus c. If we differentiate it, that will give us the gradient function. So that's 4x plus 1. And we know, because the gradient of the tangent is -3, the gradient value has to be -3 as well. So we can rearrange this to find out what the x-coordinate has to be. So the x-coordinate has to be -1. So my graph's not very realistic, but it'll do. If we find the y-coordinate as well, So at x equals 1, y, using the quadratic, y needs to equal 2 lots of minus 1 squared, take away 1, take away 10, which is 2 take away 1, 1, minus 9. So this coordinate here is actually minus 1, minus 9. So what we now have is a point on our tangent line. So in y equals minus 3x plus c, we know that there's a point minus 1, minus 9 on that line. So if we substitute those values in, this has to work. The left hand side has to equal the right hand side. So what does c need to be to make that work? Well, c needs to be negative 12. So that's two different methods to help you find out c. If you didn't like the first one, you might prefer the second one. The first one's the way I would normally go. It's just how I interpret the question. But I've done those two methods in case you prefer the alternative method there at the bottom.